So here I'm going to start adaptive RAG. So what is adaptive RAG? Adaptive RAG is very smart and very intelligent as compared to other RAG. So here you can see adaptive RAG equals to self-correcting, self-routing plus self-grading, grading retrieval augmentation generation system. Okay, self-correcting. I mean correct by its own. Okay, self-routing. It decide route by on. Self-grading retrieval. It means it will give you a self-grading retrieval augmentation generation system. Like it doesn't just retrieve an answer, it adapts its behavior based on the type of question, whether it need correct vector database or web search, the relevance of the retrieval document, and whether the final answer is grounded and useful. So here I'm going to start. Okay, so here I'm showing you it's a working. Okay, like how can we code with the help of adaptive RAG. Okay, so here I'm going to import these things, environment and setup. So load API keys for OpenAI and Tably, a web search tool. Okay, where Tably is a web search tool. So you use OpenAI for LLM, embedding Tably for external web search. Okay, now building index vector store. Okay, so create a fetch vector database of document relate to. Okay, agent architecture, prompt engineering, and adversarial LLM attack. This form your local knowledge base. Okay, so here I'm going to create a first of all I need to load document. Okay, this is a web web document. Okay, these are the URLs. Okay, and here I'm using OpenAI embedding. Okay, and here you can see I import some libraries like LangChain text splitter, recursive import recursive character text splitter, that it will split our text. Okay, LangChain community document loader, import web base loader. Okay, so these are the web base URL. And from LangChain community dot vectors, import files whatever. Okay, so FAISS. From LangChain OpenAI, import OpenAI embedding. Okay, so uh, this will create embedding like if model can't process text directly, so you need to create its embedding. Embedding means convert character or text into a numeric format or in a vector format. Okay, so here you can see this is for I mean loading the document. So here I have created a variable that is called a docs. Okay, so here inside web loader, this one, here I'm going to pass URL and dot load, that it will load for URL and URL, that it will load all URLs one by one. That's why we are using for loop here. Okay, so document list item for sublist in doc for item in a sublist. Okay, this is the document list for items inside the documents. Okay, now I am going to split by using text splitter. So here text splitter equals to recursive character text splitter dot tick token encoder. Okay, okay. And the text splitter that use tick token encoder to count length. Okay, so here you can see chunk size is 50 500 and chunk overlap is 50. Okay, that it will create a small chunk and it will also create a chunk overlap. Okay, now document split equals to text splitter split document doc list. Okay, so here after splitting document, add this thing into a vector store. Vector store, what is vector store? That store vectors in a vector db. So vector store equals to, this is our this is the already available vector database. So vector equals to files dot form document. Okay, what is form document? Document this one, return vector store initialized from form document and embedding. Okay, it took this kind of argument, document embedding and keyword argument. Okay, but here we took document equals to doc to split. Okay, and here embedding equals to OpenAI embedding. Okay, and retriever equals to vector store as a retriever that we retrieve it. Okay, Now now we can see routing layer. Okay, decision making after uploading document here, after uploading document, uh, we did splitting and like chunk overlapping, and after this embedding and store in a vector database. Okay, now agent should uh, agent should decide routing, like where should I go, in which path should I need to go or follow this, which path I need to follow. Okay, so here the LLM decides. If the question is about the agent LLM topics, use vector store. Okay, if the question is about agent LLM topic, it will use vector store. If question is general, like who won the cricket World Cup, use web search. Okay, so adaptive RAG can route query dynamically depending on the topic. Okay, so here I'm going to create. I'm going to write. I'm going to explain routers. So here you can see from typing input literals. Okay, from I already explain you what is literal in previous videos. So especially typing from the defined literal type. Okay, a value type, this is a form. This form can be used to indices to type a checker that corresponding variable or function parameter has a value equivalent to the provided literal or one of the several letters. Okay, so here you can see from LangChain core dot prompt import chat prompt template. Okay, that we can write a prompts from LangChain OpenAI import chat OpenAI. So from typing import base model field. So router query, here you can see base model, and this is the description of router query. Router use a query to the most relevant data source. Okay, so data source here literal like vector data source, vector store and web search. Okay, so we have two data source, vector data source and web search. Here inside the field description, given a query question, choose to a route choose to a route to it to web search or vector store. Okay, given a user question, choose to route it to a web search or vector store. So here you can see LLM with function call. So LLM equals to chat OpenAI model. I'm going to use this model. Okay, and temperature equals to 0. Temperature show you randomness. Okay, so structure LLM router, this is the variable. Now I'm going to use LLM dot with structure output router query, that we got structure output. Here you can see like I'm going to explain you prompt. So here this is a system prompt. You are an expert router at routing user question. Okay, so this is the inside the doc string we have prompt, system prompt. Okay, so router equals to chat prompt template dot from message. So here we can use system message and human message. Okay, this is the variable system and question, import variable by human. Okay, so question router route prompt structure LLM router. So print question router invoke who won the cricket World Cup 2023. Okay, so here it is using web search. Okay, so print question router dot invoke. So what are the type of agent memory? Okay, it will show you vector store. Okay, now retrieval grade. Okay, so here in retrieval grade, um, in retrieval grade here class, this is the class of grade document based model. Binary score for relevant check or relevant document. Binary score str field description document are relevant to the question, yes or no. So it will give you a score like document relevant or not. Okay, to the your query. So here LLM with function call. So LLM equals to chat OpenAI AI. So the model, this one is the model GPT 4o mini, and temperature equals to 0. So structure LLM grade equals to LLM dot with structure output grade document. Okay, so here this is the prompt, system prompt. You are a grade assistant, relevance of retrieve document to the user query. Okay, so this is for guidance of the system. So this is called like system prompt. So here grade prompt, here I'm going to use chat prompt template, dot from message, human message or system message. Okay, so here retrieval grader equals to grade prompt and structure LLM, this one grade prompt and structure LLM grader, this one LLM with the function call. Okay, so after this question equals to agent memory and content, doc equals to retrieval dot invoke question, doc test doc page dot content, print retrieval grader dot invoke questions. Okay, so here after this after route I mean retrieve grader that it is relevant or not relevant. Okay, so here I'm just finding out that this query I mean this question or query related to uh, documents or not. Okay, so here after this we are going to use rag generation. Okay, so use retrieval document. So here we can use I mean we are going to use retrieval document user question and generated the answer. So here you can see and generate from LangChain import hub that we can use we can like pull prompt from the model. Okay, from this one prompt equal to hub dot pull, and this is the model for prompt. And here you can see prompt core output parser import output parser. Okay, so here this is the LLM model, this one, and temperature this one. Okay, so format document post processing return, and we are going to join document here. Okay, this is the chain rag chain equals to prompt pipe operator LLM pipe operator structure output parser. Okay, so here we got chain rag chain, that is called a rag chain. So generation equals to rag chain dot invoke context document question and print generation. Okay, so this will give you agent memory is a LLM power. Okay, so this is the answer. Now hallucination grade. So like check whether the generated answer is grounded in the retrieved fact. Yes, actual and consistent. No, hallucination trigger a hallucination means like if it is give you a wrong answer or you already knew about the answer, so like this will give you as if it is factual or consistent answer. In hallucination this will give you no trigger or retry, so this is called a hallucination. Here hallucination grade. So data model grade hallucination, this is the description of this class, binary score description answer is grounded in the fact, yes or no. Okay, like this answer is grounded in the facts, so yes or no, so it will decide that is yes or no. Like now LLM with the function call, LLM equals to chat OpenAI, this is the model and this is the temperature, this is the prompt, system prompt, human and system message inside the prompt. Now hallucination grade equals to hallucination prompt, this one, and structure LLM grade, and hallucination dot invoke document generation and here this one binary score as this one factual and consistent, there is no hallucination. Okay, so answer grader ensure that the generated answer actually address the question, if not the pipeline goes back and retry by rewriting the question. So answer grade data model equals to grade answer binary score access answer address question. Okay, so here these are the binary score and this is the description answer address the question yes or no. This is the LLM call, LLM equals to chat OpenAI model equals to this one and temperature this one, structure LLM grader LLM with structure output grade answer. So this is the prompt. Okay, so answer prompt equals to chat prompt template dot form. These are the message, and this is the same process before I did. Here I'm going to create chaining it. Answer grade equals to answer prompt pipe operator structure LLM grade. Okay, so this is the chain. Answer for answer grader. Name is answer grader. Now I'm going to invoke answer from this question generation. Okay, so you can invoke question and generation from this. Now question rewrite. If document are irrelevant or the answer isn't good, LLM rewrite the question into a more searchable version. If document are irrelevant or answer isn't good, LLM rewrite the question into a more searchable version. Semantic optimization. So here you can see LLM equals to chat open AI model this one and temperature equals to this one. So this is the prompt. Okay, now we are going to rewrite that if answer is not relevant. Okay, so system equals to system, human equals to, this is the for human, and this is a, here is the initial question, this is the input format as an improve the question. Now question rewrite prompt LLM, and that we got output. Here we are going to rewrite the prompt. Okay, now we can invoke from this. Now we are using web search tool. If vector doesn't help, RAG switch to the real-time tably web search to fetch the updated data. So here LangChain underscore community dot tool dot tably search import tably search result. Web search tool equals to tably search result and k equals to 3. K equals to 3 means top 3. So adaptive flow, after this adaptive flow LangChain logic. So, the LangGraph part connect all this as a stateful flow. Node, web search, fetch the web data, retrieval, get vector from the vector database, grade document, keep relevant one, generate, make final answer, in transform, query, retrieve the question. So here you can see from typing import list, from typing extension import type dict, class grade state type dict. This is the description of this class, question generation and document. Okay, so here from langchain.schema import document. Here we are going to retrieve, so retrieve document. Okay, this is the description of this function and print retrieval. Okay, document equal to retrieve here we are going to retrieve document retrieval dot invoke question from document. Okay, here we can return by using this line document and question. Generate, after retrieving we need to generate. This is the description of this function, print generate, this is the question and this is the document. And now applying rag generation. Generation equals to rag chain dot invoke content document question and return these things. Now for grading means relevant data. Make the final, sorry, grade means keep relevant one and make final answer and generate. This is the description of this function. Okay, print relevant document, this is for question and this is for document. Now score that now we are going to check by using this condition. Here filter document equals to empty list that we store here, store each document. So for D in document score equals to retrieve document retrieve grader dot invoke. Okay, the question here I'm going to pass question and page content. Okay, so grade dot binary score, if grade equals to H means document are relevant, we can filter and append this document as not relevant, then we can continue and return document filter document and question. Okay, after this is the transform query. So this is the description of transform query. Print transform query, this is question, this is for document. Now we are going to rewrite this for better question and return this one. Now we can make web search. So web search, this is the description of this function. Print web search, this is the question. So web search equals to web search document equals to web search tool dot invoke the query from the query of the question from the web. Okay, and join the content one by one by using loop in the document here you can see web search result, document, page content and web result. Return web result and question. Here now I am going to create edges. This is for router question. This is this function for route question. Print route question. This is the question. This is the source. If source dot data source web search, this is going to print and return web search. Elif source dot data source equals to vector source, print route question to the RAG and vector store. Decide to generate. Okay, so here this is for description for this function. I'm going to print this. This is for question. This is for document. Not filter document. If not filter document, other document have been filtered and check relevance. Okay, we will regenerate a new query. Okay, so here I'm going to print this one. And return the transform query. Print decision generate and return generate. Now grade generation document and question vector core. Now grade generation vector document and question. Now grade generation versus document and question. Okay, so this is the description of this. Print this one. This is the question. These are the document and generation score that we can check if grade equals to S. Then print generate is grounded in documents. It check questioning answer grade answer generation versus question. Score equals to answer dot grade dot invoke. This is the question and generation. Grade score dot binary grade equals to score dot binary score. If grade equals to S, decision generation address the question. Return useful. Else generation that does not address the question. Return not useful. Else here you can see decision generation is not grounded in document retry. Return not supported. After this we are going to create a graph. Okay, this is for initialization the graph. These are the nodes. Okay, web search retrieval grade document generate and query. Okay, now we are going to build graph. So here add workflow dot add conditional edges start and route question. So like if you want to web search or if you want to go search from vector database. Okay, so here we are going to use these two conditional edges. Workflow dot edges, these are the edges for web search retrieval, and here this is a code for conditional edges create document and decide to generate. Okay, this one. Now workflow dot edge transform query and retrieval, and this is the conditional edge generate grade generation versus document and query. Not supported generate useful and not useful transform query. Compile equals to here I'm going to compile app.workflow compile. So here you get app.invoke question is what is machine learning. Okay, so this will give you answer this one. Okay, and what is the agent memory, this will also show you this one. Okay guys, I hope you like my video. Bye bye, take care.